The nature of space and time has long been a vital question in science and philosophy. It invites exploration into whether these concepts are fundamental entities that make up the universe or if they emerge from something more basic. It is important to know that the universe includes everything, all the stars, planets, galaxies, and even the empty space between them. When contemplating the universe's size, many wonder if it goes on forever or if there is an end somewhere out there. One approach to this question looks at the shape of the observable universe. Extending approximately 93 billion light-years, some models suggest that the universe is flat, which means it could extend indefinitely in all directions, implying that it is infinite. Other models propose that the universe is curved, like the surface of a sphere. In this case, if you travel far enough in one direction, you could theoretically return to your starting point, indicating a finite universe but with no true edges. Throughout history, great thinkers have pondered the universe's structure and size. In the early days, space and time were seen as fixed backgrounds where events occurred. Isaac Newton described space as an absolute, unchanging stage, while time flowed uniformly. This view dominated for centuries, offering a comforting framework for understanding the world. In the early 20th century, things began to change dramatically with Albert Einstein's theories of relativity. Einstein introduced the idea that space and time are interwoven into a single continuum known as spacetime. According to his theory, the presence of mass and energy can curve this spacetime, showing that space and time are not as fixed or absolute as once thought. Instead, they behave differently depending on the observer's speed and gravitational fields. This twist in perspective sparked a lively debate among scientists and philosophers. Some argue that space and time are indeed fundamental. They believe that they form the very foundation of reality, shaping how we experience the universe. In this view, every particle and force exists within this three-dimensional space over a duration of time. Conversely, other theorists propose that space and time might be emergent phenomena. This notion suggests that instead of being fundamental building blocks of reality, space and time arise from deeper, more fundamental processes or structures in nature. One idea comes from the realm of quantum mechanics, which implies that the particles that make up everything we see might not be the most basic units. Some scientists hypothesize they could come from something more abstract, like information, entanglement between particles, or tiny vibrating strings. Researchers using approaches like loop quantum gravity and string theory continue to explore these concepts. Loop quantum gravity attempts to reconcile quantum mechanics and general relativity, suggesting that space itself may be quantized, consisting of tiny loops. In this model, space could emerge from the underlying network of these loops, adding more weight to the idea of emergent space. Despite ongoing debates and research, the scientific community remains divided. Experiments and observations have yet to provide definitive evidence favoring one view over the other. The intricacies of quantum physics and the nature of black holes present challenges, as they hint at a reality that may be extraordinarily different from our everyday experiences. As scientists push the boundaries of knowledge, the exploration of space and time continues to evolve. The development of new theories and technologies helps to bridge the gap between understanding and mystery. Even as researchers delve deeper into black holes, cosmic inflation, and the early universe, the discussion surrounding space and time compels consideration of what is fundamental and what is merely an illusion we experience. Ultimately, the question of whether space and time are fundamental or emergent remains open. As humanity's understanding of the universe expands, this fundamental inquiry will likely shape our comprehension of reality itself. The journey into the heart of space and time is ongoing, a captivating quest that reflects the curiosity and persistence of those who seek to understand the universe we inhabit.